Welcome, curious minds, to AI History of Western Philosophy.
Great to be here.
Today, we're embarking on a journey into something truly remarkable, I think. A pattern that's just so persistent and, frankly, a bit enigmatic. It pops up across philosophy, science, even, the way we tell stories.
Yeah, it's everywhere once you start looking.
Exactly. We're talking about the profound significance of the number 3. It feels almost like a secret handshake between completely different fields of knowledge, doesn't it?
It really does.
From the rhythm of a perfect phrase to, well, the very fabric of matter itself. And we're going to kick off this exploration with an ancient, maybe often overlooked philosopher named Ion of Chios, and his audacious, almost prophetic claim. All things are 3.
Quite a statement to start with.
Right. So our big mission today, as we dive into articles, research, historical accounts, is to figure out why. Why does this triadic structure keep reappearing? Is just, I don't know, coincidence, a trick of the mind.
Or something deeper.
Yeah, is it a fundamental blueprint, woven into the very universe? Or maybe it's more about us, a reflection of how our own brains are simply wired to comprehend and organize reality. We'll be looking for those aha moments, those surprising facts.
And hopefully connecting some dots across history.
Exactly. Now, before we properly jump into Ion's world, a quick but important note about what we do here at AI History of Western Philosophy.
Good idea.
Our aim isn't really to be philosophers ourselves. We're more experimenting with philosophy as material, seeing if we can generate new possibilities for thought based on the sources we explore. And just a reminder, AI-generated content, specifically this podcast, can confabulate. It can present ideas as facts sometimes.
Right, it's pattern matching, not reasoning in the human sense.
So while we strive for accuracy, and we'll always try to point you to the original sources, our core mission is really about sparking new perspectives, maybe asking new questions, not just delivering dogma.
And what's truly fascinating about the specific topic, this threeness, is that the very first question immediately connects ancient Greek metaphysics with ideas we're still, grappling with in modern particle physics. It's quite incredible.
It makes you wonder about those deep, almost hidden connections across fields that seem entirely separate, doesn't it?
Absolutely. And as we explore these examples today, I really encourage you, the listener, to keep asking yourself, why 3? Is it truly fundamental, intrinsic to the cosmos? Or is it maybe our human perception, our cognitive framework that's shaping how we see patterns, leading us to find 3 everywhere? That distinction, I think, is going to be a crucial thread throughout our discussion.
Okay, so let's unpack this. Let's start with the philosopher who kicked it all off with such a bold claim. Ion of Chios. He's often, as I said, relegated to footnotes, but he absolutely deserves a spotlight here.
Definitely.
Imagine he lived from around 490, maybe 480 BC, down to about 420 BC. So smack dab in the middle of the Athenian Golden Age. It's an incredible period of creativity and thought.
Right in the heart of it all.
Yeah, he wasn't some quiet academic cloistered away. He was right there in the mix, part of that vibrant cultural and political scene. He knew, he talked with, he even commented on some of the biggest names of his era.
People like Simon, the statesman.
Exactly, Simon. And Sophocles, the legendary tragedian. Even Socrates himself. Ion wasn't just born on Chios. He moved to Athens, really immersed himself in that buzzing intellectual environment.
And his output was apparently huge.
Prodigious is the word. Ancient sources call him a polymath, like a real Renaissance man before the Renaissance. Famous for his polyideia, which just means incredible versatility. He seemed to master almost every major literary genre.
Tragedian poet.
Yeah, he was a successful tragedian, won prizes. There's even a story, maybe apocryphal, who knows that he celebrated a win by gifting every single Athenian a pitcher of Chian wine.
Wow, that's quite a celebration.
Isn't it? But he also wrote lyric poetry, elegies, hymns, paeans. And prose, too, historical accounts, like a foundation of Chios and these things called epidemiae, which were like memoirs, maybe even early biography. Plutarch used them for vivid eyewitness accounts of famous people.
So he was observing and writing about everything.
Exactly. And this incredible versatility, this ability to see connections across all kinds of human experience, from poetry to politics to personal lives, that's what likely honed his mind to spot these bigger universal patterns. It probably led him straight to his big philosophical insight about threeness.
Makes sense. His broad experience might have given him a unique perspective.
I think so.
Yeah.
And it's within this huge body of work that we find the core of his philosophical idea. In a treatise apparently titled Triagmos, which, well, it just means threeness.
Very direct.
Right, only fragments survive, unfortunately, but they pack a punch. The main one, the cornerstone, was preserved by a later writer, Harpocration. And it gives us the essence of Ion's thought. Here it is. All things are three, and there is nothing more or less than these three.
Wow. No ambiguity there.
Not at all. And he continues. Of each one thing, the excellence, Areto, is a triad. Intelligence, synesis, and power, Kratos, and fortune, Taicha.
Okay, so let's break that down a bit.
Yeah, just think about that first part. All things are three. This isn't just like an observation. It's a massive universal cosmological claim. He's saying the fundamental structure of everything, all of reality, is triadic, like a metaphysical law.
A blueprint for everything that exists.
Exactly. But then he goes further. He extends it to the realm of value, saying the areto, which is a rich word meaning excellence or virtue or maybe functional quality.
How well something does its job, essentially.
Right. The areto of each one thing is also a triad, and he names them. Intelligence, power, and fortune. Now, intelligence might sound like it only applies to conscious beings, right?
Like people or maybe gods.
But we have to remember, in his time, thinkers like Empedocles believed nature itself was imbued with some kind of sensation or perception. So maybe Ion saw intelligence, synesis, as a more universal quality, like inherent order or fitness.
Interesting. So it could apply to a star's function or a general strategy or even a well-built ship.
That seems to be the idea. He was aiming for universality. Excellence in anything is this combination of intelligence, power, and fortune. And that word he used, triagmo, seems pretty unique. Possibly his own invention, maybe to distinguish his idea from the Pythagorean trias.
Yeah, that's a crucial distinction to make later. But if we step back, the sheer boldness of this, especially for the 5th century BC, is striking. He's not just noticing threes, he's proposing the single universal principle that links the structure of the cosmos, the what is with ethical value, the what is good or excellent, all under one roof, so to speak. That's incredibly ambitious.
There really is.
And his breakdown of archetype, intelligence, power, fortune, it really makes you wonder, doesn't it? What does it mean for excellence to be triadic? Are they equal parts? Is it a balance, a hierarchy, or some kind of dynamic interplay between them that defines true quality?
Right, like you need all three, maybe in different measures depending on the thing.
Perhaps. It suggests excellence isn't simple. It's this complex three-part harmony, not just one single quality. That challenges us right away to look beyond easy definitions.
And here's where it gets really interesting. Because Ion's big claim about a universal threefold structure immediately puts him in dialogue with, well, arguably the most influential intellectual force of his time, the Pythagorean tradition.
They're the numbers guys.
Exactly. While many of his fellow Ionians back home, like Thales with water or Anaximenes with air, were searching for a single material first principle, an arch.
The stuff everything is made of.
Right. The Pythagoreans down in southern Italy were proposing something way more abstract, number itself. For them, all things are number. The universe wasn't just stuff. It was a harmonious system governed by numerical ratios.
A cosmos ordered by math, essentially.
Precisely. And within that worldview, the number 3 held this special, almost sacred status. It was often called the perfect number because it embodied completeness. It had a beginning, a middle, and an end.
Which resonates perfectly with Ion saying nothing more or less than these three.
Exactly. It feels complete. And the connection gets even deeper when you look at Aristotle writing later. He mentions the Pythagoreans linked the triad to the 3 spatial dimensions. You know, a line needs 2 points, a surface needs 3 to define it, a solid body implies volume. 3 dimensions define a complete physical object.
So Ion's big cosmological claim could be seen as a direct philosophical application of that Pythagorean idea.
That's how it looks. It's like he took their abstract principle and said, okay, let's apply this universally. It represents a really crucial conceptual pivot in Western thought, doesn't it? Moving from asking, what's the world made of? To what's the fundamental pattern or structure of the world?
Absolutely, a shift from substance to structure. That laid groundwork for Plato, Aristotle, so much later philosophy.
And Ion, being an Ionian by birth, but clearly influenced by these Italiad ideas, kind of acts as this fascinating bridge. He's taking a Pythagorean-style answer number structure and applying it back to that original Ionian question about the fundamental nature of reality.
That's a fantastic point about him being a bridge. But, and this is important, it seems his relationship with Pythagoreanism wasn't just simple acceptance. He wasn't just drinking the Kool-Aid, so to speak.
Oh, what makes you say that?
Well, we have another fragment, this one reported by Diogenes Laertius. Ion is talking about the philosopher Pherecydes having a nice afterlife, but then he adds this little qualifier. If indeed Pythagoras was really wise.
Ah, if indeed. That little phrase changes everything.
Doesn't it? It carries this clear skeptical overtone. It suggests Ion wasn't just a follower. He seems to have embraced the explanatory power of their numerology, the idea of number as a key principle, but maybe kept a critical distance from some of the more mystical stuff.
Like maybe the transmigration of souls or the stricter cult-like aspects.
Exactly. It paints a picture of Ion not as a member of some rigid school, but as a critical, independent thinker, someone actively engaging with the cutting-edge ideas of his time, taking what he found compelling, but maintaining his own judgment.
Which is really the mark of a true philosopher, isn't it?
It really is, and it raises a great question for us, even today. How do you adopt a powerful framework like the Pythagorean focus on number without uncritically swallowing every single part of it? It speaks to real intellectual independence.
Okay, so we've seen this ancient seed planted by Ion. Now, let's jump forward quite a bit, a couple millennia actually, and see how this idea of threeness shows up in our modern scientific understanding of the cosmos.
Right, from ancient intuition to modern physics.
And the most immediate, the most fundamental triad we experience is, well, space itself, the three dimensions. We just know reality works this way: length, width, height. Or you could say forward, backward, left, right, up, down. Three independent directions.
Our basic container for reality.
Exactly. And this intuition got formalized beautifully back in the 17th century with Cartesian geometry. Descartes showed definitively that you need three coordinates, x, y, and z, and only three, to pinpoint any location in physical space. Necessary and sufficient.
The bedrock of classical physics.
Absolutely. It's the stage where Newton's laws, all of classical mechanics, played out. Now, Einstein came along with relativity and expanded our view to four-dimensional spacetime.
Which sounds like it breaks the pattern.
Well, not quite. Because even in relativity, there's still a crucial distinction between the three spatial dimensions and the one temporal dimension. It's still often talked about as the 3+1 framework. Space and time are linked, but they aren't interchangeable. The three of space remains distinct.
Okay, got it. It's
Yeah.
still a fundamental three in there.
Yeah. And here's the part that absolutely blew my mind when I first learned it. This threeness of space isn't just like a convenient description. It seems almost necessary for the universe to work the way it does. Think about fundamental laws like gravity and electromagnetism.
The inverse square laws.
Exactly. Newton's gravity, Coulomb's law for electric forces, they both follow that 1/r² relationship. And that mathematical form turns out to be stable specifically in three spatial dimensions.
Whoa, really? So if space had, say, 4 dimensions, gravity wouldn't work the same way.
Apparently not. Orbits might not be stable. Atoms might not hold together properly. There are even these anthropic arguments, a bit speculative, maybe suggesting that a universe with a different number of dimensions just couldn't support the complexity needed for life.
So our existence might actually depend on space being 3-dimensional.
It seems plausible. Now, sure, you have theories like string theory proposing extra tiny, curled-up dimensions.
Beyond our perception.
Right. But our observable macroscopic universe, the one we live in, is resolutely 3-dimensional. So this triad of dimensions isn't just how we describe things. It's arguably the fundamental container of reality, ensuring its very stability.
That's truly remarkable. It elevates it from just a description to, well, a profound condition for everything else. The stability of planets, atoms, maybe even us, it seems, tied intrinsically to this spatial threeness. It really feels like a fundamental blueprint.
Okay, now let's dive even deeper. Let's go microscopic, down to the fundamental bits of matter itself. One of the most profound and honestly perplexing discoveries of 20th century particle physics is this. The elementary particles, called fermions, the actual building blocks of matter, show up in exactly 3 distinct generations, or families.
Right. The Standard Model lays this out very clearly.
Yeah. Our best theory of matter, the Standard Model, organizes all the known quarks and leptons, the 2 types of fermions, into this neat triadic structure. So generation 1, you've got the up quark, down quark, the electron, and the electron neutrino.
The familiar stuff. Protons, neutrons, electrons, making atoms.
Exactly. That's the stuff that makes up you, me, this desk, everything stable around us. But here's the astonishing part. Nature provides 2 more complete copies of this family.
Like photocopies.
Almost exactly. Generation 2 has the charm quark, the strange quark, the muon, which is like a heavy electron, and the muon neutrino. Then generation 3 has the top quark, the bottom quark, the tau, even heavier than the muon, and the tau neutrino.
And the weird thing is, they're identical in almost every way except
mass. It's baffling. Particles in the higher generations are basically clones of their generation. One counterparts, same electric charge, same spin, same way they interact with forces, but they are incredibly heavier. The muon is like 200 times heavier than the electron. The tau is about 3,500 times heavier.
Which makes them unstable.
Highly unstable. Because they're so massive, they decay almost instantly into their lighter, more stable generation 1 cousins. We basically only see them fleetingly in really high-energy situations like inside particle accelerators or when cosmic rays hit the atmosphere.
So the big question, the multi-billion-dollar question really is, why?
Exactly. Why? 3 generations. This triplication of matter is one of the deepest unsolved mysteries in fundamental physics. There's no accepted theory that explains it. It's not derived from first principles.
It's just there. An empirical fact we plug into the model.
Pretty much. It's an observed pattern, an unexplained parameter of our universe. But the evidence for exactly 3 is super strong. For instance, precise measurements of how the Z boson decays, that's a carrier of the weak force, show it decays into exactly 3 types of light neutrinos. That strongly limits the number of generations to 3.
So it really seems like the laws of nature decided to write themselves in triplicate here. A fundamental, unexplained threeness right at the heart of matter. For our purposes today, this seems like a clear case of a contingent, empirical fact 3 that just is, but we don't know why yet.
Okay, let's drill down even further. Inside the protons and neutrons themselves, let's talk about the force that binds quarks together, the strong nuclear force. The theory describing this is called quantum chromodynamics, QCD.
A very successful, if complex, theory.
And central to QCD is the idea that quarks carry a type of charge, kind of like electric charge, but it's called color charge.
Not actual colors, of course.
No, just whimsical names. Unlike electric charge, which is just positive or negative 2 options, color charge comes in 3 types: red, green, and blue. And there's a fundamental rule in QCD called color confinement. It basically says that only combinations of quarks that are color neutral or white can exist freely in nature. You never find a single quark floating around on its own.
Right, they're always bound together.
Exactly.
Right.
Now, you can get color neutrality by combining a quark of one color with an antiquark of the corresponding anticolor, like red and anti-red. That makes a type of particle called a meson. But for stable matter, for the protons and neutrons that make up atomic nuclei, the crucial combination is the baryon.
Protons and neutrons are baryons.
Right, and a baryon achieves color neutrality by being made of exactly 3 quarks.
Yeah.
And each of those 3 quarks has to have a different colored charge. 1 red, 1 green, and 1 blue, like mixing primary colors of light to get white.
Red plus green plus blue plus white, or color neutral.
Precisely. And what's absolutely fascinating here is that this requirement for 3 quarks isn't just some arbitrary rule they came up with. It's a direct mathematical necessity arising from the structure of QCD itself. The theory is based on a mathematical group called SU3, special unitary group in 3 dimensions.
The 3 is right there in the name.
It is. And that mathematical structure mandates the existence of exactly 3 fundamental charges, the 3 colors. So the stability of every single atomic nucleus in the universe, and therefore all the matter we see, relies fundamentally on this deep triadic symmetry.
Wow. So this threeness isn't just observed like the particle generations. It's baked into the mathematical structure.
Exactly.
It's a profound mathematical necessity. If KCD is right, there have to be 3 color charges for stable protons and neutrons to exist. Without it, the universe as we know it couldn't hold together.
It connects right back to Ion of Chios, doesn't it? His idea of a structural arch.
It really does. Here, the fundamental structure isn't a substance, but a mathematical symmetry, SU3, that dictates this absolutely essential triadic nature. This feels like a true blueprint case.
Okay, let's shift gears from subatomic particles to the building blocks of life itself. Because threeness is also absolutely fundamental in biology, specifically in how genetic information is stored and translated. We're talking about the genetic code.
The language of life.
Right. The instructions in our DNA that tell cells how to build proteins, which do basically everything. And this code, it's a triplet-based system. The information is stored as a sequence of 4 chemical bases, A, C, G, and T, or U in RNA.
Adenine, cytosine, guanine, thymine.
Yep. But when the cell reads this sequence to make a protein, it doesn't read it one base at a time. It reads it in non-overlapping groups of 3. Each little 3-letter word is called a codon.
And each codon means something specific.
Exactly. Each codon specifies either one of the 20 standard amino acids, the building blocks of proteins, or it acts like punctuation, signaling stop translation here. Now, why 3, why not 2 or 4?
Ah, the efficiency argument.
It's pure mathematical necessity, really. Think about it. If you use single bases as codons, You'd only have 4 to the power of 1, which is 4 possible words, not nearly enough to code for 20 amino acids plus stop signals.
Okay, so tripairs.
Doublets, yeah. 2 bases per codon gives you 4 squared equals 16 combinations. Still not enough. You're short.
So triplets.
Triplets gives you 4 cubed equals 64 possible codons. That's more than enough. You have enough words to specify all 20 amino acids plus start and stop signals, and you even have leftovers.
Redundancy. Multiple codons meaning the same amino acid.
Exactly. And that redundancy or degeneracy actually makes the code more robust. A small error, a mutation, might just swap one codon for another that means the same thing, so no harm done.
Clever, like a built-in error correction.
Sort of. And this triplet code is nearly universal across all known life. It got established really early in evolution, maybe a kind of frozen accident that just worked so well it stuck.
And became the foundation for everything else.
Right. There's even recent research suggesting a kind of higher order structure, a triplet of triplets, where the codons on either side of the one being read can influence how it's translated. So the triad is even more deeply embedded than we thought.
That genetic code example is fantastic. It shows threeness as this minimalist, super efficient solution. It wasn't arbitrary, it was almost forced by the math. 4 bases over 20 amino acids triplets are the simplest way to make it work.
Less wouldn't work, more would be too complex.
Exactly. It really highlights how mathematical constraints shape evolution. So this threeness isn't just a blueprint, it's a blueprint of minimal logical necessity.
Okay, moving at the biological ladder now, right to the top. The highest level of classification. Our modern understanding of the entire tree of life is also fundamentally structured as a triad.
You're talking about Carl Woese and the domains.
Exactly. Back in 1990, the brilliant microbiologist Carl Woese and his colleagues proposed the 3-domain system. This was truly revolutionary stuff based on comparing the genetic sequences of ribosomal RNA, which is this core piece of cellular machinery found in all life.
Before him, it was mostly just prokaryotes and eukaryotes, right? Or maybe 5 kingdoms.
Yeah, the old view was simpler. But Woese's genetic analysis revealed a much deeper tripartite split. He showed that all cellular life falls into 3 primary domains of descent: bacteria, archaea, and eukarya.
Bacteria are the familiar ones. Eukarya are us, plants, fungi, anything with a nucleus. But archaea was the big surprise.
Absolutely groundbreaking. These archaea look like bacteria under a microscope. They're prokaryotic and often live in crazy extreme environments like boiling hot springs or super salty lakes. But genetically, Woese showed they are as different from bacteria as both are from us eukaryotes.
And in some ways, more closely related to us.
That's what later research suggested. Many molecular features of archaea are actually closer to eukaryotes than to bacteria. So these 3 domains, bacteria, archaea, eukarya, represent the 3 most ancient, fundamental branches stemming from LUCA, the last universal common ancestor.
A deep 3-way split at the very root of life.
Exactly. Now, the model gets refined, of course. Some scientists now argue for maybe a 2-domain tree, with eukarya branching out from within the archaea. But the point is, Woese's work fundamentally reshaped biology by revealing this deep, initially triadic structure to life's entire history.
Right, and this brings up a really crucial point for our overall mission today. We need to think about the nature of these different triads we've looked at. They aren't all the same kind of 3, are they?
Good point. How would you categorize them?
Well, think about it. The 3 color charges in QCD seem necessary. They fall right out of the math, the SU3 symmetry. If the theory's right, it has to be 3.
Okay, necessary 3. What else?
The genetic code feels like a logically necessary minimum. Given 4 bases and 20 plus amino acids, 2 isn't enough, 3 is the simplest that works. It's driven by informational requirement.
Right. Efficient 3.
Then you have the 3 spatial dimensions. That feels like a fundamental empirical feature. We don't know why it's 3, but its properties seem essential for stability. It just is, and it's crucial.
Empirical 3. No.
And at the other end, maybe, are the 3 generations of matter particles. That looks like a purely contingent fact as far as we know. No theory predicts it, we just observe it. 3 copies for reasons unknown.
Contingent 3. And the domains of life.
Woese's domains are a powerful classification based on evolutionary data. It revealed a deep, tripartite branching pattern in life's history. So maybe a classificatory 3.
Necessary, minimal, empirical, contingent, classificatory.
Exactly. Making these distinctions is crucial if we want to philosophically understand why 3 keeps showing up. It's not one single thing. It's this multifaceted pattern emerging from different levels: mathematical necessity, logical efficiency, empirical observation, maybe just plain contingency, and how we categorize things. That really complicates the simple answers like, it's all a blueprint, or it's all coincidence.
It's much richer than that. Okay, so what happens when we move from the physical world into the more abstract realms of logic, math, and pure thought? Does 3 play a role there too?
Absolutely. And maybe the most tangible example is the triangle.
The simplest polygon. 3 sides, 3 vertices.
And mathematically, it's the archetype of structural stability. There's a fundamental theorem in geometry. A triangle is uniquely determined by the lengths of its 3 sides. Unlike, say, a square or a pentagon, which you can flex into form even if the side lengths stay the same.
Right, a square can become a rhombus.
Exactly. But a triangle is inherently rigid. Its angles are fixed by its sides. You can't change its shape without changing a side length.
And that's why engineers love them.
Precisely. That unique rigidity is why triangles are the absolute fundamental building block in stable engineering. Think bridge trusses, roof supports, geodesic domes like at Epcot, radio towers. They're all networks of interconnected triangles.
Because they handle stress so well.
Exceptionally well. Any force on a corner gets distributed along the sides as pure tension or compression. No bending forces at the joints, which are weak points. It's incredibly efficient. So it's a physical manifestation of a geometric truth.
Perfectly put. And let's not forget the Pythagoreans again. They obviously revered 3, but they also explored the triangle concretely with things like the Pythagorean theorem relating the 3 sides of a right triangle and their study of Pythagorean triples.
A plus basic bismays. 3 numbers.
Right. So there's this beautiful elegance in how an abstract mathematical property, the rigidity of the triangle, translates directly into building strong, stable things in the real world. It feels like a universal principle of structural integrity, echoing that stability we saw in the 3D cosmos.
Okay, what about even more abstract logic? Well, in formal logic and math, threeness provides a foundation for order through something called the Law of Trichotomy.
Trichotomy. Sounds important.
It is. It's an axiom, a fundamental assumption that applies to any set that's totally ordered, like the real numbers we use every day. It says for any 2 elements in that set, let's call them x and y, exactly 1 of 3 possibilities must be true.
Only 1. And what are the 3?
The 3 possibilities are 1 point x is less than y, xy, 2 point x is equal to y, xy, y, 3 point x is greater than y, xy.
Less than, equal to, or greater than. That seems obvious for numbers.
It feels obvious, but its power lies in being exhaustive and mutually exclusive. Exactly 1 must be true. There's no 4th option, like they can't be compared. And you can't have 2 true at once, like x being both less than and equal to y.
Okay, so it guarantees a clear comparison.
Precisely. It removes all ambiguity. This triadic principle is the formal bedrock for all sorting algorithms, for putting things in order, which is fundamental to so much math and computer science. It's important to remember, though, it's not a law of nature, like physics laws. It's a definitional axiom for what totally ordered means.
It defines the rules of the game for ordering things.
You got it. Its power is clear when you compare it to sets that aren't totally ordered, where elements can be incomparable. So the law of trichotomy shows the triad as this logical necessity for creating a complete linear hierarchy, for eliminating fuzziness in comparison.
So not a physical 3, but a logical 3 needed for order in abstract systems.
Exactly. It's a logical blueprint for organizing information clearly and unambiguously. Without it, much of math would grind to a halt.
Okay, shifting gears again, let's jump to 19th century Germany. G.W.F. Hegel. His dialectic is probably the most famous philosophical use of a triadic structure, right?
Absolutely famous, and also famously misunderstood.
Yeah, that simple thesis-antithesis formula.
Which Hegel himself barely ever used. It oversimplifies things quite a bit.
So what is the Hegelian dialectic, really?
It's a dynamic developmental process. It starts with a concept or maybe a historical situation that's just taken as given, immediate. Hegel called this the in itself, like an initial statement, simple being.
Okay, stage 1, the in itself, thesis, maybe?
Sort of. Then, through analysis, this initial stage reveals some kind of internal contradiction, something inadequate about it. This leads to its own negation, its opposite. This is the stage of for itself. It defines itself by opposing the first stage.
Stage 2, negation, opposition, antithesis.
Roughly. But the crucial third stage isn't just splitting the difference. It's what Hegel called Aufhebung. It's a fantastic German word.
Means like to sublate.
Exactly. And sublate captures the triple meaning. It means to cancel the contradiction, but also to preserve the partial truths from both the first and second stages, and finally to lift them up into a new, higher, more comprehensive whole. This synthesis is the in and for itself.
Wow. Cancel, preserve, lift up. That's much richer than just synthesis.
Much richer. And this triadic movement, this rhythm of in itself, for itself, in and for itself, Hegel believed this was the fundamental engine driving everything. The logic of concepts, the unfolding of world history, the development of spirit, Geist.
Everything follows this pattern.
For Hegel, yes. His whole philosophical system, like in his encyclopedia, is built as this huge nested structure of triads upon triads. It's not just a tool for him, it is the structure of reason and reality itself. The way spirit comes to know itself. That's mind-bending. So for Hegel, the triad isn't just describing things, it's the active force making things happen, making consciousness and history progress.
That seems to be the claim.
Viewing progress itself as inherently triadic. That's a profound philosophical blueprint for development, isn't it? Not just observing threes, but seeing three as the engine of change.
Absolutely. But long before Hegel, way back in ancient Greece again, Plato proposed his own foundational triadic structure, this time for the human inner world.
Ah, the tripartite soul.
Exactly. In dialogues like The Republic and the Phaedrus, Plato argues the soul, the psyche, isn't just one thing. It's made of three distinct parts, each with its own desires and functions.
What are the three parts again?
First, there's the rational part, the logisticon, located in the head, Plato says. This is the part that loves truth, seeks knowledge, reasons, calculates, our intellect.
Okay, reason at the top.
Then second, the spirited part, the thymoids, located in the chest. This is where our emotions live: anger, ambition, courage, the love of honor and victory. Think of it as willpower or righteous indignation.
The emotions, the drive.
And third, the appetitive part, the epithemicon, down in the abdomen and genitals. This is the seat of our bodily desires: hunger, thirst, sex drive, the desire for money to satisfy those urges, the raw appetites.
Reason, spirit, appetite.
Right. And Plato gives that amazing allegory in the Phaedrus: the soul is a chariot. Reason is the charioteer, trying to guide two winged horses. One horse is noble and cooperative, that's the spirited part. The other is wild, unruly, always trying to pull downwards. That's the appetitive part.
So reason needs help from spirit to control appetite.
Exactly. The charioteer's job is to get them working together, using the spirited horse to keep the appetitive one in line and steer the whole chariot towards the heavens, towards truth. For Plato, a just and virtuous person is one where these three parts are in harmony, but a hierarchical harmony.
Reason rules, spirit enforces, appetite obeys.
Precisely. And this internal structure becomes his blueprint for the ideal city-state too. Philosopher kings embody reason, the soldiers or guardians embody spirit, and the farmers and merchants embody appetite, a macrocosm of the soul.
It really makes you think how these ancient models still resonate. And notice the pattern again. You often get two elements in tension, like appetite and reason, maybe, and a third element, spirit, comes in to mediate, to resolve, to create a stable, functional whole.
Yes, spirit acts like the bridge or the enforcer between the high and the low.
It suggests this deep, maybe archetypal function for three as the number of resolution, the number that creates harmony or stability out of duality or conflict. A really profound psychological insight even now.
Okay, let's unpack this from a slightly different angle now. Why do we seem to find triads so appealing? Why do we like things in threes?
The cognitive angle.
Yeah, there's a really compelling explanation from cognitive psychology. It's often called the rule of three. Basically, information presented in groups of three seems to be inherently more memorable, more satisfying, maybe even more persuasive than other quantities.
Like our brains are just wired for it.
That seems that way. Think back to George Miller's classic 1956 paper on short-term memory, the magical number 7 plus or minus 2. We could only hold so much in mind at once. So to handle more info, our brains use chunking, grouping things into smaller, meaningful sets.
And 3 is a good chunk size.
Apparently, it's the best chunk size for creating a pattern. One thing's just a point, 2 things make a line, a comparison, but 3 things that creates a pattern with a beginning, a middle, and an end. It feels complete, resolved. Our brains just seem to latch onto that structure.
Ah, the beginning, middle, end satisfaction.
Exactly. And you see this cognitive preference everywhere. It's the absolute foundation of the classic 3-act structure in storytelling. Setup, conflict, resolution, done.
Like almost every movie or play.
Pretty much. It's the power behind those catchy rhetorical troikolons, Julius Caesar. Vidi, vidi, vici. I king, I saw, I conquered. Bam, bam, bam. Or the French motto,
Yeah.
liberté, égalité, fraternité.
Even advertising slogans, right? Snap, crackle, pop.
Totally. It
Yeah.
sticks in your head. So this suggests that at least some of the threeness we perceive, especially in things humans create, philosophy, myths, stories, speeches, might actually be a projection of our own minds.
Yeah.
We structure the world in threes because that's how our brains like to process it.
That's fascinating. It highlights that interplay between objective reality and our subjective cognitive machinery. Even if it is partly a cognitive artifact, its influence is huge. It shows how our internal sense-making tools shape the structures we see and build in the world.
It blurs the line between out there and in here.
Beautifully put. So for our mission, this definitely points towards threeness being, at least partly, a powerful reflection of how our minds comprehend reality.
But that cognitive explanation, powerful as it is, doesn't quite feel like it covers everything, does it? It doesn't fully explain the triads in physics, like color charge or particle generations.
Right. Those seem more fundamental, less about our perception.
So maybe there's a deeper, more metaphysical interpretation going on too. Building on that idea we just discussed, the triad as resolution. Maybe the number 3 represents a kind of universal archetypal structure for any dynamic process, any system undergoing change.
A blueprint for process itself.
Kind of. Think about it in 3 logical stages. Stage 1, undifferentiated unity. An initial state, simple being a starting point, like a single geometric point. Immediate, no internal conflict yet.
Okay, unity.
Stage 2, differentiation and opposition. That unity gives rise to its own negation, or a second element appears, creating duality, tension, conflict. The process gets going. Geometrically, at a second point, now you have a line, opposition between 2 poles.
Duality, tension.
Stage 3, integration and synthesis. The tension between stage 1 and 2 gets resolved. A third stage emerges that incorporates both earlier stages into a new, more complex, stable whole. Resolution, reintegration at a higher level. Geometrically, at a third point off the line, now you have a plane, a stable triangle.
Unity, opposition, integration, position, negation, synthesis.
Exactly. This abstract structure seemed to underlie so many of the triads we've looked at. It's explicit in Hegel's dialectic. It's implicit in Plato's sole reason, unity, contending with appetite, opposition, to achieve justice, synthesis, mediated by spirit.
It's the physical reality of the stable triangle.
It's the narrative arc of storytelling. Stable beginning, disruptive conflict, resolved ending. From this viewpoint, maybe 3 is fundamental because it's the minimal structure needed to describe a complete cycle of change, conflict, and resolution.
That connects a lot of threads. It suggests 3 is fundamental not just mathematically or cognitively, but because it maps onto the very logic of process, how things come to be, face challenges, and reach a new state. It bridges the cognitive and the cosmic, a potential blueprint for process itself.
So if that's the case, it's hardly surprising that when humans try to grasp the ultimate reality, the divine, they also often reach for triadic structures. It feels like we project this archetype of process onto the biggest questions.
Divine triads, triple deities, they pop up everywhere in mythology and theology.
Yeah, it seems like a powerful way to think about unity and diversity within the Godhead, or the fundamental forces at work in the cosmos. The most philosophically developed example has got to be the Christian doctrine of the Trinity.
One God in 3 persons, Father, Son, Holy Spirit.
Right. It posits one God, one divine essence or ousia, existing eternally as 3 co-equal, co-eternal persons or hypostases. It's incredibly sophisticated. It's trying hard not to say there are 3 God, that's tritheism, and not to say God just wears 3 different masks, that's modalism.
It's trying to hold on to both the oneness of God from Judaism and the distinct divinity of Christ and the Spirit from the New Testament.
Exactly. And you can even see it as this dynamic relational model within God. The Father eternally begets the Son, the Spirit eternally proceeds from the Father and the Son, depending on the tradition. It's like an eternal process, a dynamic relationship within the single Godhead.
A divine process mirroring that metaphysical triad.
Perhaps. And you find a parallel structure, though distinct, in Hinduism with the Trimurti.
Brahma, Vishnu,
Shiva, right. Personifying 3 cosmic functions. Brahma the creator, Vishnu the preserver, Shiva the destroyer or transformer. Again, not seen as 3 competing gods, but different facets or roles of the ultimate reality, Brahman, representing that endless cosmic cycle. Creation, sustenance, dissolution.
Another dynamic 3-part process.
And you find others too, like the Egyptian triad of Osiris, Isis, and Horus, It seems to be a recurring pattern when trying to articulate the ultimate.
And interpreting these through that lens of the metaphysical archetype makes sense. They become symbolic ways of expressing the dynamic, multifaceted nature of reality creation, preservation, transformation. It's humanity structuring its understanding of the divine using that same triadic logic of process.
Reflecting both cosmic processes and maybe our own cognitive need for that complete structure.
Exactly. It's a powerful example of us using threeness to make sense of the ultimate blending cognitive patterns with perhaps a deeper reality.
So our whole inquiry kicked off with that fragment from Ion of Chios, the mostly forgotten guy who just flat out said, all things are three.
Seems less forgotten now.
Right. Our journey across physics, biology, math, philosophy, religion, it shows his claim wasn't just a random guess. It was this truly remarkable intuition, an early glimpse of a pattern that just keeps showing up, woven into reality and how we think.
His triagmos was ahead of its time.
Yeah, his formulation, probably rooted in Pythagorean ideas about number, somehow prefigured structures science wouldn't uncover for millennia, like the SU3 symmetry behind the three-color charges binding quarks.
Or the triplet structure of the genetic code essential for life.
Or that weird, unexplained empirical fact of 3 generations of particles. And, of course, the 3 dimensions of space we live in.
So back to the mission you set out. Is it coincidence, blueprint, or reflection of mind?
What's the verdict?
Well, the fascinating thing is it seems to be all of the above. It's this incredibly complex tapestry. Sometimes, like QCD color charge, it really does look like a necessary mathematical blueprint. Matter literally couldn't work otherwise.
Okay, blueprint check.
Other times, like the particle generations, it's this undeniable empirical pattern, maybe contingent, maybe hinting at a deeper blueprint we just haven't found yet.
Empirical fact, maybe blueprint, maybe coincidence. Check.
And then there's clearly a huge role for our own minds, that rule of 3, that need for beginning, middle, end. We seem wired to find and create triads, so it's also very much a reflection of how we comprehend reality.
Cognitive reflection.
Check. Ion of Chios, way back then, had this amazing intuition about this complex, multi-layered pattern. He really was at a pivotal moment, wasn't he? Shifting focus from just what stuff is made of to what's the underlying structure.
Or material arch to structural arch.
Exactly. Declaring that the first principle was a number 3 was this philosophical seed with enormous potential. And you could argue that much of the history of thought since then, Plato's soul, Hegel's dialectic, Woody's domains, Gelman and QCD, has been, in a way, the slow cultivation of that very seed.
Wow.
The triad seems to be, simultaneously, a feature of the cosmos, a fundamental category of abstract thought, and an indispensable tool for the human mind to make sense of it all. The enduring echo of Ion's triagros isn't a single answer, but the persistent, multifaceted power of 3 itself.
So what does this all mean for you, listening right now?
Well, maybe the takeaway is that the power of 3 isn't simple. It's not just one thing. But it is this incredibly potent lens for viewing reality. So maybe next time you encounter a set of 3, a story in 3 acts, a concept split 3 ways, even just, 3 main points in an argument.
Or 3 ingredients in a recipe.
Yeah. Consider not just the items themselves, but why 3 feels so complete, so stable, maybe just so, right? Is that threeness revealing something deep about the world itself? Or is it revealing something deep about how you make sense of the world? Or maybe, just maybe, it's doing both at the same time.
A question worth pondering.
Definitely. Thank you so much for joining us on this deep dive into AI, history of Western philosophy. Keep exploring, keep questioning.
And keep noticing those 3s.
We'll see you next time.